Hey guys, GCSE STEM here. In today's video, we are going to be learning about gravitational potential energy. So we start off with what gravitational potential energy is. Gravitational potential energy is the energy stored by an object lifted against the force of gravity. So this means if an object is lifted from the ground above, it will gain potential energy, and if an object is falling from the sky, it will lose potential energy. So if we talk about the energy changes during these processes, if an object is lifted, then the energy will be changed from the person's chemical energy to the person's kinetic energy. And then if an object is falling from a certain height, the height will turn from the gravitational potential energy all the way to the kinetic energy as the object is moving and is no longer stationary. So if we look at the formula for gravitational potential energy, the formula is EP, which is gravitational potential energy in joules, which is known as J, equals M, mass in kilograms, times G, which is the gravitational field strength in Newton per kilogram. And on average, in Earth, it's 9.8, but in most cases it will be used as 10, times the height in meters. So if we start off with what gravitational field strength is. The gravitational field strength, denoted on G, on Earth is approximately 10 newtons per kilogram. The gravitational field strength on the surface of the Moon is much less than it is on Earth. This means it would be easier to lift a mass on the Moon than on the Earth. The gravitational field strength on the surface of the gas giants, for example Jupiter and Saturn, is more than on Earth. This means it would require a lot more force to lift a mass on the gas giants in comparison to Earth. So here you can see a quick diagram denoting the amount of mass you would need to lift up objects. So you can see right on the lower end, on the right, is the Moon with 1.7, and you can see Earth, which is 9.8. The heaviest object is the Sun, which has a gravitational field strength of 293.0 newtons kilograms. So if we go on with this question, the question says, a man with a mass of 70 kilograms climbs a flight of stairs that is 3 meters higher than the floor. The gravitational field strength is approximately 10 newtons per kilogram. Calculate the increase in its gravitational potential energy store. Using the formula below, and the formula from the previous slides, please pause the video and attempt to answer this question. Okay, welcome back. First, we would write down the mass of a man. The mass of a man, it says, is 70 kilograms. Secondly, we would go on to write the gravitational field strength. The gravitational field strength is 10 newtons per kilogram. And thirdly, we would write the height, and in this case the height is 3 meters. So now we get our formula, and the formula is EP equals mgh. So if we plug in our values into the formula, we get EP, or gravitational potential energy, is equal to 70 times 10 times 3. And if you do that on a calculator or in your head, you can get 2,100 joules, and that would be our final answer. So as a summary, gravitational potential energy is the energy stored by an object being lifted against the force of gravity. The formula for gravitational potential energy is EP equals mgh. If an object is falling, it loses gravitational potential energy, as its gravitational potential energy is being converted into kinetic energy as the object is moving. And if an object is lifted against the force of gravity, it gains gravitational potential energy. That was GCSE STEM. If you enjoyed the video, please like, comment and subscribe. Thank you.